This video is about arc length and sector area. For theta d is the angle in degree. Theta r is the angle in radian. Suppose this arc length is L, corresponding to the central angle theta d. That means this angle is in degree. How you work out this L? We know for the circle, the circumference is 2 pi r. The central angle for a circle is 360 degree equals, since the central angle given is theta d, so I write down here is theta d. What's the arc length? I use L stand for that. So we solve for L. Then you can do cross multiply. Same line go to denominator. So 360 degree go to denominator. Then you have theta d times 2 pi r. This is the arc length when central angle is in degree. If we are given the angle in radian, then how you figure out this arc length? We know for 180 degree, that equals pi. This over theta d, that's angle in degree. This is theta r. We use this equation to figure out the relationship between theta r and theta d. Theta d. You will get cross multiply, pi go to denominator, 180 degree times theta r, angle in radian. Now we plug in here, we use this one to substitute for this theta d. We will get theta d is 180 degree over pi times theta r. Then this one is 360 degree. Then times 2 pi r. This is a complex fraction. Pi we can drop down to the denominator so that we will get this 180 degree times theta r, angle in radian, then times 2 pi r over pi times 360 degree. Then we can reduce 180, 360, it will be 2. Here's the pi reduce, 2 reduce. So only you have theta r times r left. In other words, if you are given the angle in radian, then your arc length equals the central angle in radian times radians. Let's talk about the sector area. Still, for theta d is the angle in degree. Theta r is the angle in radian. The shaded area is A. How you figure out this A? We know that for a circle, the area is pi r squared. The central angle for a circle is 360 degree. If the central angle is theta d, what's the area will be? Then you can do cross multiply. A equals, the same line go to denominator. That's how you get the 360 degree as denominator. Then theta d times pi r squared. We already know this theta d equals 180 degree over pi times theta r, which means the central angle in radian. Now we will plug this into this theta d now. You will get 180 degree over pi times angle in radian over 360 degree times pi r squared. Since this is a complex fraction, so we will move pi into denominator. We will get 180 degree over pi times 360 degree times central angle in radian, then times pi r squared. Then we can reduce 180, 360, that is 1, here's 2. Then pi is gone. So we have 1 over 2 central angle in radian, then r squared. This will be the sector area when the central angle is given in radian.